Hello, welcome to Economics for Everyone. Today we will see one of the most famous situations used to understand game theory, that is prisoner's dilemma. It was introduced by Albert W. Tucker in the 1940s and since then has been used as a very nice example to understand all the notations of game theory. The situation goes as follows. Two suspects are arrested in a crime, Jim and Jane. But since there is little evidence in their crime, police wants to extract a confession. So the police authorities come up with a deal. The deal is if you confess to the crime and your partner does not, you will be set free while your partner will be given jail of 6 years. For example, if Jim confesses to the crime while Jane does not, then Jim will be set free as he has cooperated with the police authorities in telling the truth, while Jane will be given jail of 6 years. The next deal is if they both confess, that is, both Jim and Jane confess to the crime, they will be given jail of 3 years. But if they both deny to the crime, then they'll be given jail of only 1 year since there is lack of evidence. So, now let's convert this situation into a game. First, let's see who the players of the game are. The players are the Jim and the Jane. However, there is police authorities also, but since her actions are already predictable, we need not to take her as the player of the game. Players are only Jim and Jane as they have to make the decision in the game. Next, let's see what the strategies of the game are. There are two strategies available to both. That is, first, they can either confess to the crime or they can either deny. So we can write these strategies of both the suspects in their sets. That is, Jim's strategy set denoted by S1 comprises of either confess or deny. And similarly, Jane's strategy set denoted by S2 is the same, that is, either he can confess or he can deny to the crime. Now let's see the payoffs. Now we have converted the game into the payoff matrix. This summarized form of a situation is called the normal form of the game. The other thing is that each entry in each of the cells in the matrix represent the utility that the suspects assign to the various present terms. But utility is subjective and hence it could vary, but for simplicity we assume to be negative of the length of the present terms. Let's see here that if Jim confesses to the crime and also Jane confesses, then both will be given jail of 3 years. Hence we have represented this with -3 and Jane's utility also by -3. The green entries show the payoffs to the Jim and the entries in black show the payoffs to Jane, that is utility assigned to the Jane. But let's see what the outcome will be. We know that they're both in different prison cells, hence they cannot communicate, and we also know that they're hardened criminals, so they'll think about themselves first than about the other, and they have no sense of loyalty towards one another. So now let's position firstly into the place of Jim and see what will he do. He supposes that if Jane confess, then what will Jim do? He has two options, either to confess or deny. So here, if he confesses, he gets jail of 3 years, and if he denies, he gets jail of 6 years. So obviously, he will choose to confess, that is 3 years of jail. Now if he thinks if Jane denies, then what will Jim do? Again, he has both options, confess and deny. If he confesses, he gets 0 years of jail, and if he denies, he gets 1 year in jail. So obviously, again, he will choose to confess. So Jim will always confess no matter what Jane does. Now let's position ourselves into the place of Jane and see now what will he do. Similar strategy Jane applies that if Jim will confess, then what should I do? He has two options, either to confess and deny. And if he confesses, he gets 3 years of jail, and if he denies, he gets 6 years of jail. So he will confess. If he now thinks that Jim will deny, then what will Jane do? If he confesses, he gets 0 years in jail, and if he denies, he gets 1 year in jail. So he will again choose to confess. So Jane will also decide to confess no matter what Jim does. So we found out that Jim will also confess no matter what Jane does, and Jane will also confess no matter Jim does. So both of them will confess to the crime and get 3 years in jail. This is also called the dominant strategy of the game, that is to confess. That is, no matter what the other person do, I will choose to confess. And this kind of strategy is called dominant strategy. And this is the outcome or the result of the game. Though they had better option, that is a 1 year in jail to both, but they choose to confess, and the outcome will be 3 years in jail for both of the criminals. So, hence we can write the dominant strategy is a strategy that is best response to all other players' strategy. Let's see this mathematically. Here I is the number of players in the game. It could be 5, 7, 10, any. So SI star, that is a particular strategy chosen by the ith player, if it is the best response to all other players' strategies, then SI star is called the dominant strategy of the game. Here minus I represents the strategies of all other players except the player I. So SI star is the dominant strategy, that is the best response to strategy of all other players. One last thing to note is that we saw that the dominant strategy of the game, that is the outcome of the game, is to confess, that is both the players in the game are given 3 years in jail. But this is a Pareto inefficient outcome, as both the players can be made better off by choosing to deny, because here they get 1 year in jail, while if they confess, they get 3 years in jail. This is the Pareto efficient outcome, but since there is no way for the players to coordinate or trust each other, the outcome or the solution of the game will be to confess. So, this was all about the prisoner's dilemma. Stay tuned for more videos on game theory. Thank you.